Welcome to Brain Vision.
Hi everyone, so what we're looking at here is we have cold water at a temperature of 20 degrees Celsius entering a steam generator, and at the outlet this water leaves as a saturated vapor at the boiler pressure. What we're asked to find is the pressure at which, when the heat required to reheat the liquid into its saturation temperature, is equal to the heat required to vaporize the liquid at its boiler pressure. The first thing we're going to do is go ahead and write down the enthalpy of liquid water, so that's HF, at 20 degrees Celsius. And by looking this value up in the table, we find that this is equal to 83.91 kilojoules per kilogram. Now remember that we're asked to find the pressure at which the heat required to heat the water up back to its saturation temperature is equal to the heat at which the vaporization occurs. So therefore what we have is that Q preheat is equal to Q boiling. Now we can write this in terms of enthalpies and say that Q preheat is equal to HF at T saturation minus HF at 20 degrees C, and we can write Q boil as HFG at T sat. So remember that we do know what HF at 20 degrees C is, and that's 83.91. So what we have is HF at T sat minus 83.91 is equal to HFG at T sat. So rearranging the terms, we know that HF at the T saturation minus the HFG at T saturation should be equal to 83.91 kilojoules per kilogram. So as you can see, the saturation temperature that's selected and its corresponding enthalpy values should lead to a difference of 83.91 kilojoules per kilogram. So what we're going to have to do is select a temperature and by trial and error, solve this problem. So by plugging in the enthalpy values that we see from table A4, we'll find that the temperature that satisfied this condition is going to be temperature T saturation is equal to 310.6 degrees C. Now this corresponds to a saturation pressure of 9.94 MPa. And this is our final answer.